Hi everyone. My name is Shai. I'm the CEO of SkillReal, a deep tech company that address the following problem. The problem is that today, when you build, for example, a manufacturing plant, let's think about automated manufacturing plant, you have a fully simulated digital twin. You build a complete manufacturing plant with thousands, millions maybe of parts, and everything is simulated as perfectly working on the digital twin. But then you have to build this factory, and this is where the challenge starts. And this process of bridging the gap, this is where we are getting into the picture. We are helping to bridge the gap between the digital twin and the physical twins, and to make all this process by far more effective. And this process costs to the industries tens of billions of dollars. This process of how I take a digital twin and actually build it, or how I did a change on the digital twin and actually build it. And this is the problem that we are addressing. So how are we solving this problem? So on the technology side, we have a proprietary patented technology that uses together a LiDAR depth camera with an RGB camera and computer vision and points cloud algorithms that fuse it all together. And the bottom line, what it is actually enabling us is to align and put the digital twin on top of the physical twin. And when you do this alignment, you can do almost anything you want. For example, you can see AR visualization, like you see here on the side. This is a real factory where the gray part is actually a digital twin. It's actually digital, the representation, the visual representation of the digital twin in the physical world. And then you can, for example, align the robots or the fixture or the clamps, whatever you want, with a part that is not even yet produced on the pressing. You can save a few weeks because you don't have to wait. So this is just an example. There are many, many other examples. So another thing you can do is, because our solution is real time, it's not like digital scanning and things like this. You see in real time the physical twin and the digital twin, and they are aligned together. What you actually can do, for example, is to move the digital twin to fit to the physical, but also move the physical to fit to the digital. Think about it like an iterative process of building a new physical twin according to a digital twin. And sometimes you come to a factory and you see a wall and you have to adapt to change the digital twin. So it's like both sides iterative solution. Another advantage we have is we are fully integrated into the design systems. So every change you do is actually echoed into the design system. So you build, it's really enable all this process to be very effective. And we also collect big data, which enable later all kind of analytics, traceability, sharing information, sharing problem, and so on. So what is the value proposition we supply? So I will give it just by example. One of our customers, which is actually the biggest car manufacturer in the world, they have, for example, the following issue. They have to switch from model 21 to model 22. Now it takes them 30 days of work. They are doing it in weekends. So instead of manufacturing, they are stopping the line and do these adjustments to the manufacturing cells. And each day they produce about 1,200 cars. So just think how much does it cost them. So each such a day costs them more than $10 million. And I'm not talking about the risk of not hitting, of making the things on time and so on. So this is one use case when you actually, we call it ramp up. We shorten the ramp up stage. There is also bigger challenges, like for example, when you do retooling, when you take a diesel manufacturing factory and you switch to electric vehicle line, this is then much bigger. It's much more than 30 days. It's many months. And then, of course, the savings are much higher, and so on. When you build a new manufacturing plants, like, for example, in the case we have with GM, it's cost $2.something billion. And of course, we can save significantly on these costs. So what we are solving is a real, very, very painful problem. So this is some use cases. There are two main use cases. One is when the digital twin is in a way fixed. It's like you build according, we call it build as planned. You have, for example, an engine and you want to build it according to the plan. And this use case we have with these customers. For example, Baker Hughes, the energy company, they build the turbine, very complex 3 meters turbines, and they are using our system in order to build it and to do the inspection and reduce the errors and save a lot of costs and from errors and from the time it takes also to produce such things. Also BAE Systems, which is a large aerospace company, they are building complex assemblies. Sometimes it's very small batches with very, very high cost of error. So when there are very high cost of errors, our system really helpful for them. You can see here again on the right how we can identify, for example, a missing screw. And if you think about a radar, it's not exactly screws, but there are about 1,000 parts that you have to put very, very accurately. And each part that is not in place is a problem. And now that the other use case that we discussed before is aligning manufacturing lines. So here you can see, for example, a robot and a virtual prototype. So with VW, we are retooling for electric vehicle manufacturing line. With BMW, we do a new car model. So actually, we help them to take the digital twin of the manufacturing line of the new model and commissioning and make it the physical twin aligned. And new factory with GM. There are also weld point inspection. There are two main use cases. One is for the actual manufacturing, but we are more focused on during the ramp up. When you build a manufacturing line, each deviation in the weld point means that something is wrong on the manufacturing cell or with the robot program. So this is like a tool. It's closed the loop. It's saying we don't have the time to go into it, but it's actually closed. We know which robot did which deviation, and we can help to solve the problem. Another thing very important is safety manufacturing cells. So you want to check a manufacturing cell, you put the digital twin into the real physical manufacturing cell, and you can do alignment and check actually that it doesn't hit anything on the floor. And you have to remember that manufacturing cells are very dynamic.
No, we need to move fast. Sorry.
Okay, so why now? So I think it's very clear why the things are. This is the digital twin markets. And this is some quotes from customers. And this is a few words about us. So we are 11 employees. We won the award from Startup Nation. We won grants, several grants. And we have OEM agreement with Siemens, which is the world leader in our field. And we also integrated our technology into Siemens systems. And we already sell many of our sales through the Siemens channel. We also have technology collaboration with NVIDIA and others. And I will be glad to answer any questions you have.